Alright, let's solve a system of equations with matrices. And this technique is actually known as Gaussian Elimination. So let's suppose we have matrix A, and to express the system of equations as a matrix, we're simply going to write the coefficient of each variable. So we have 2x, so we write 2, plus y, well that's just plus 1y, so coefficient is 1, minus z, well that's minus 1z, which is just minus 1. And we're going to do this for the other two equations as well. So go ahead and write negative 3, negative 1, 2, we have negative 2, 1, and 2. And now what about the right side of the equations? Well, we can separate left hand and right hand side with this vertical bar, and we are going to write 8, negative 11, negative 3, the values given here. Alright. So now that this is an augmented matrix, we want this matrix in echelon form, meaning we want these three values in here, right over here, to be equal to 0. Alright. It's also known as triangular form, I believe. Anywho, the first step into making this into echelon form is to make these two values equal to 0 first. So how do we make negative 3, or let's take a look at line 3 first. How do we make negative 2 equal to 0? Well, if you take a look at line 1, we have 2 over here. 2 plus negative 2 is 0. So if we add line 1 and line 3, we will get this value over here equal to 0. Now I'm just going to copy down line 1 since we're not really changing any values yet. Alright, so let's add line 1 and line 3. So 2 plus negative 2, that is 0. That's exactly what we want. 1 plus 1, that's 2. Negative 1 plus 2, that is 1. 8 plus negative 3, that is 5. And now we want this value of line 2, this x value, to be equal to 0. Now we can do something very similar. If we multiply line 1, by 3 over 2, well, the first value here, 2, if we multiply that by 3 over 2, so 3 over 2 times 2, 2's cancel, and we have 3. So 3 plus negative 3, that's 0. So we definitely want to do this. We want to multiply line 1 by 3 over 2 and add that to line 2. So we already did the first part, 3 over 2 times 2, that is 3. 3 minus 3, that is 0. 1 times 3 over 2, that is 3 over 2. 3 over 2 minus 1, well, that's just the same as 3 over 2 minus 2 over 2, which is 1/2. Similarly, negative 1 times 3 over 2, that is negative 3 over 2. Negative 3 over 2 plus 2 is the same as negative 3 over 2 plus 4 over 2, which is also 1/2. Then we have 8 times 3 over 2. Well, that is just 4 times 3, which is 12. 12 plus negative 11 is 1. So this is the first step in solving system of equations. Alright. Now in echelon form, we also need this value right here to be equal to 0. So how can we do that? Well, if we multiply line 2 by negative 4, we get negative 2 right here. And negative 2 plus 2 is 0. So line 1 is going to stay the same. We're not changing anything from line 1. So I'm just going to copy line 1 down. Same with line 2. We're not going to change line 2 as of now. We're just focusing making this equation, or sorry, this augmented matrix into echelon form. Okay, so -4 times 1/2, that is -2. -2 plus 2, that is 0. So -4 times 1/2, -2. -2 plus 1, that is -1. And then let's do the same thing for these two values over here. 1 times -4, that's -4. -4 plus 5 is equal to 1. So after that, what we want to do is now make these two values equal to 0. So how do we go about doing so? Well, let me just write this down really quickly. Line 3 is going to stay the same, so I'm just going to copy everything down. 0, 0, -1. Then we have this vertical bar and 1. So let's see what we can do here. Now if you notice, you have line 3. Alright, if you take a look at line 3, if we multiply that by 1/2, well, we can cancel this value right here, and this will be equal to 0. So why don't we just do that? Multiply -1 by 1/2. This is equal to 0. 0, I mean, let's take a look at this first. Nothing's really going to change since this is just 0, so this value over here in the middle, 1/2, will be the same, as well as the one right here. So we have this equal to 0. Now we have to focus on the right hand side. So 1 times 1/2. 1 times 1/2 is just 1/2. 1/2 plus 1, that's 1/2 plus 2/2, which is just 3/2. Now if we subtract line 1 and line 3, well, that's, we have -1 minus -1, i.e. -1 plus 1, and that is 0, which is what we want. So let's go ahead and do that. Let's add line 1 and line 3 together. We have 2, 1, 0, and then we should also have 7 right here, because 8 minus 1 is 7. Alright, let me move this down even more. Yes, this is quite long. So something we can do to make this easier to work with is multiplying line 3 by -1, so we have a positive value for the coefficient. So we have 1, -1, 0, 0. Now you may be wondering how we can solve the rest. Well, if we multiply line 2 by 2, we also get this equal to 1, it's equal to 3, so you know the values of z and y. Now, using what we have from line 2, we can get rid of this value right here in line 1. So if we subtract, we get 2, 0, 0, 7 minus 3, that is 4. Now what if we divide line 1 by 2? We have A is equal to this matrix. So divide line 1 by 2, we get 1, 0, 0, 2, 0, 1, 0, 3. I'm just copying down the rest right here. And would you look at that? There's 1, 1, and 1, they're all in different areas. And recall that these are just the coefficients of each variable. So now we know the value of every single variable. And this matrix right here, matrix A, has a unique set of solutions. So recall, this was x, this is y, this is z, you can write it as that. So we know that x is equal to 2, y is equal to 3, z is equal to -1. And we have our answer right here with the use of matrices. Thank you for watching. I'll see you later. Bye bye.